Okay, let's go ahead and fill this table in. So the oxidation numbers for the cations, and so when we're looking for the cation oxidation numbers, everybody use positively charged. So I've got two things in here. Which one of these is positive? Which one's negative? And how do you know?
Cation is positive.
How do you know which, if the H or the F, which one of those two atoms is the cation and which is the anion?
Is the cation.
Okay.
Because it's in column 1.
Because it's in column 1? No. This is a binary compound. We okay with me saying that? Two things in it. Which one is negative? What's the rule? So what's the rule for a binary compound about cations and anions?
The more electronegative element in a binary compound is negative.
Yep, that's it. So I look at a binary compound, the first thing I need to say is which one of these is more electronegative? That's pretty easy because fluorine's the most electronegative, so then it's automatically going to be the negatively charged one. So then that makes my hydrogen positively charged, and then I can look at my rules and see that if hydrogen is with a nonmetal, which fluorine is, then its charge is +1. So then we can write down that the cation's oxidation number in this case, hydrogen is a +1, and then that makes the fluorine automatically a -1, plus its rule says that it's a -1. And name it. So what's the name of this guy?
Hydrochloric acid.
Acid. Starts with an H, right? So hydrofluoric acid. All right, how about the second one? How do you know which one's the cation? The metal's going to be the cation. We know that for a couple of different reasons. One, it's calcium, so it's always going to be +2. 2, it's a metal, so they can only give electrons away, so that makes it a cation. 3, oxygen is more electronegative, so that makes it the anion for sure. So then my calcium is a +2, my oxygen is a -1, or -2, and the name for this? Calcium oxide. And this one's very simple in its naming because the calcium's charge is unvariable, right? It's always negative, or it's always +2. So I don't need to tell you it's +2 because it's always +2. All right, so who's the positive one and who's the negative one in number 3? We can go through that exact same line of thinking that we did for the last question, right? Cadmium's a metal, so it gives away electrons. Bromine is more electronegative because it's closer to fluorine, so that's got to be the negative one. Cadmium only has one charge in a compound. It's one of those 3 transition metals with a fixed oxidation state, and its oxidation state is +2. So then I've got a CD +2 and a Br -1, and the name of this guy is cadmium bromide. Okay. And the next one. What do we got here? So the cations. The hydrogen has to be a +1, right? How come? Nope. Because it's hydrogen and hydrogen with a non-metal, so it has to be +1. So the H is a +1. What else we got? The oxygen is a -2, And so what about that phosphorus? Is it a 6 or is it a 5? So we've got 8 negatives for the oxygen, right? And then we've got 3 positives for the hydrogen. So then it's a +5, right? And the name of this? Phosphoric acid. Okay. Charges in this next one? What do we got? Which one of those is going to be the one that's negative, the Br or the O?
Oxygen.
The oxygen is a higher electronegativity, so that guy gets to be the negative one. So we'll write down that our oxygen is a -2. And so then the bromine's charge is going to have to be what? +1? +2? +3? Do I hear 4? Anybody want to go 4? 5? Any takers for 6? I'm going with 3.
Why is that?
What's the charge on the oxygen? -2. So what's the total negative charge? -4. Are you okay with that? 2 -2s. What's this thing's charge got to be when I'm finished? I have to have 1 negative left over. So how many negatives do I have to cancel out? 3. This is a polyatomic ion with a -1 charge. So no matter what, the charge has to be not balanced. I can't make it balanced. It's not supposed to be balanced. And so if I have -2 and -2 and +3, then one of the negatives is not canceled out. That's what I'm looking for in this case. And the name for this polyatomic ion? Bromite? Yeah.
So since it has a 2 next to the oxygen, that's 2 -1?
No.
2 -2s.
2 -2s.
And then you need to take it up 3 to
Cancel 3 of
cancel
them out.
3 of them out.
Yep. So in that polyatomic ion, there's 1 bromines and 2 oxygens. And what are the oxygens' charges?
-2
Each.
each. Right?
Yeah. So then you got a max.
Oh, but you can't have it at 0 since it's a negative charge.
Right. This guy
So
has
you
to
have have
end
one.
because this polyatomic, because there's a negative charge there.
Okay.
You're not supposed to cancel out all of them. You're supposed to leave 1 left over.
Okay, I got you.
Okay. Next one. Who's the positive one? Copper is positive because 1, it's a metal, and they'll only ever be 0 or positive. And chlorine is closer to fluorine, so it's got a higher electronegativity. All right, so my chlorine is a -1. And if the chlorines are -1, then the copper has to be what? +2. Cu +2. And then the name of this? Yeah. Copper 2 chloride. How come we didn't have to write that 2 thing with any of the rest of these?
Because copper's changes.
Because copper is the only one we've got so far with a variable oxidation state. It's a metal with a variable oxidation state. The other metals that we've had so far haven't had variable oxidation states, so I don't need to include that. Okay, positively charged things in this next one. List them off. What do we got? Sodium, it's a group 1 metal, so it's +1.
Hydrogen.
Hydrogen's with a bunch of non-metals inside of that carbonate, so then it's a +1. The oxygen is a -2. So then that's -2, -2, -2 gives me -6. And now I've got a +1 and a +1, so then the carbon needs to be what? +4. The one thing I want to notice is, you guys to see is, this is an H, right? And the rule for the H's is if it's with a non-metal, that it's negative, and or positive, and if it's with a metal, it's negative. Well, there's a metal there, right? Sodium's a metal. How come I didn't call it a +1?
Because there's oxygen.
No, this thing right here, what is this?
An acid.
No, it's not an acid. It's a polyatomic ion, right? So when this goes, that polyatomic ion is a thing unto itself. So is the hydrogen with the carbonate or is the hydrogen with the sodium?
Carbon.
It's with the carbonate. That is a chunk. That HCO3 is a piece. So that H belongs to the CO3. It doesn't belong to the sodium. So it hasn't interacted with the sodium at all. All right, and the name for this guy?
Sodium bicarbonate.
Well, the name we're going to use is sodium hydrogen carbonate. Bicarbonate is an old name. The bi used to mean an H is added to it, but we're moving away from that. That's not taught anymore, but that is what that is. A bicarbonate is a carbonate with an H on it. But again, old nomenclature. So
That's what everybody's going to be using, changing to, right?
correct. You won't see bicarbonate in a textbook unless it's a reference to this is what it used to be called. But this is not what it is currently going to be called. Everything is for decades, things have been in the evolution of streaming down. Okay, silicon dioxide. So what's the formula for that?
SO2.
Not SO2, SiO2.
Yeah.
You're seeing the di prefix here, so what kind of compound must this be? It's a covalent compound, right? Two nonmetals here, silicon and oxygen. So this is a covalent compound. So in my covalent compound, I've got a binary molecule, and which one of these is more electronegative?
Oxygen.
Oxygen, since it's the second most electronegative. So then that guy is negative, and he's going to be a -2, which makes my silicon what charge?
+3. +4.
-2, -2.
Oh, yeah, since it's 2.
It's got to cancel out. Yep. Okay, next one is dinitrogen pentasulfide. So what's the formula? N2S5. Again, this is a covalent compound, right? Because we're seeing those prefixes. So which one of these is more electronegative? So the charge on the sulfur is oxygen's charge, right? It's in the oxygen column. So this is going to be S -2 and then N
Plus
+5.
5.
-2, -2, -2, -2, -2, right? So then it's -10. But there's only two sulfurs. So if I'm splitting -10 across two things, +5 and +5, and I get a cancel. Again, least common multiple. All right, ammonium dichromate. So ammonium dichromate. NH4. Now what? Why are there two of them? Why is it moving it way down there? That's weird. It's putting it in that box. Yeah, it's the polyatomic ion,
Has a charge of negative.
and the dichromate's got a charge of -2, and the ammonium ions have got a charge of +1, so then I need two of them to cancel it out. So this one's a little more to this to break it down. What I would do is I would disassemble them into their polyatomic ions and then break that down. So in an ammonium ion, it's NH4 plus. So that makes the hydrogens all +1. And if I've got +1, +1, +1, +1, and I have to leave a +1, that makes the nitrogen a -3. And in my chromates, I have to have a leftover -2, but I've got 14 negatives, 2 from each of the 7 oxygens. So if I gotta leave 2, that means 12 of them have to be canceled out. That means I have 2 chromates that each have a charge of +6. So chromates with a +6 and O's with a -2. And I would suggest you use something like the chromate, and those guys are going to equal they have to equal a -2, and each one of these oxygens is a -2. And so then if this is a +6 and this is a +6, then from this I get 12, and from this I get -14, and then that leaves me with a leftover -2. So it's obvious to see it laid out like that. Okay, so hydroxide, polyatomic ion, what's the formula for that? OH negative. Okay, so who's the negative one? Oxygen for sure. So the oxygen is a -2, and then that leaves the hydrogen as a +1 for a couple of reasons. But one of the reasons is it only needs to be a +1 because I'm only canceling out one of the two charges, leaving me with a negative. Mercury 2 iodide. So I've got Hg, and it's got a +2 charge on it, and iodides have a -1 charge on it, so I'm going to need two of those. So I'll have Hg +2 and then I negative. So when you're given something like mercury 2, you can just immediately write Hg +2 because that's what the 2 is telling you, that its charge is +2. And then we've got zinc fluoride. So zincs are +2 all the time, and fluorides are -1 all the time, so it's going to be ZnF2. And so then I've got a zinc +2 and a fluoride -1. And that's it for the table. Okay, so a name for HBr, what do we got for that? Hydrobromic? So how do you know it's an acid? Starts with an H, right? And how do you know it's hydrobromic and not bromic? There's no oxygen, so I need that hydro prefix. So here we have another hydro prefix for the fluora. So that means I've got an H and an F and no O's. And I'm done. How about the next one? H2CO3. Carbonic acid. So it's CO3 is the polyatomic ion, and so that's carbonate. And when I turn that into an acid, I add H's until the charge disappears. So it's a CO3 -2. If I put 2 + 1 H's on there, then the charge is gone. And the 8 becomes ic. So carbonate becomes carbonic acid. So I've got a phosphoric acid. So again, there's no hydro there, so that means there must be oxygen present. And so it's phosphoric. So it's phosphoric acid. That means I've got a PO4 with a -3 charge on it. And so that means if I've got a -3 charge, I'm going to have 3 H's to cancel out the -3. How about the next one? Is there a hydro with this one? Nope, because there's an oxygen there. So what's the polyatomic ion CrO4? Chrome 8. So then this is chromic acid. All right, I've got acetic acid, and so it says acetic acid. So this must have been what polyatomic ion? 8. Must be acetate polyatomic ion. And then I'm just going to write it the way pretty much everybody writes it. Is that unhappy for you? What's wrong with that? I put the H on the end instead of the beginning, right? Do you remember why we wrote the polyatomic ions formula like that instead of grouping the H's and O's and C's together? That's how it's actually drawn. So nobody actually writes C2H3O2. They just don't. They write They write CH3COO negative. So what that's telling you is I have a carbon, and there's an H, and an H, and an H. And then I have another carbon, and a doubly bonded oxygen, and an oxygen, and a minus charge. That minus charge is actually on that last oxygen. So if you were a hydrogen and you were positively charged, where would you hook up to this thing? On that oxygen on the end. So that's where this thing actually goes. I put an H right there, and the negative charge here cancels out, and there's my carbonic, or there's my acetic acid. Where do you find this acetic acid stuff? Is this a common compound? It's what's in vinegar. It's the acid in vinegar. It's the acid in ketchup. It's the acid in tomato sauce. You want to clean a penny? Put it in some ketchup. Put it in some vinegar. Be sparkly, nice and clean. Pretty much any jewelry. Anything that's dingy, just put a big old blob of ketchup into a little bowl and throw the jewelry in there, and then put it into a, I don't know, what, colander, something like that, strainer. Just spray it off and shiny, shiny. Why? Acetic acid. Chews away all the stuff that's on the outside. Okay, what's this next one? What's the polyatomic ion? That's bromate, right? So then it's bromic acid. How about this perchloric? What was the polyatomic ion if I have a perchloric? Perchlorate. So perchlorate. So perchlorate is a ClO4 with a negative charge, so then I just need one H. And then that cancels it out. What's the first thing you're looking for when you're attempting to name a chemical formula?
It has a hydrogen molecule.
So acid or ionic or covalent. It's a pretty bad T. That's an E. You cannot name the formula until you recognize, am I looking at an acid, am I looking at an ionic compound, or am I looking at a covalent compound? So for the acid, that one's easy, right? What am I looking for?
Hydrogen.
I'm looking for an H, right? Start with an H. For ionic, I'm looking for a metal or polyatomic ion. If I see either one of those, I'm looking at ionic. And for the covalent, it's a non-metal binding with a non-metal. How do you know if the compound you're looking at is ionic or covalent? Easy way to do that is metal equals ionic. Is there an exception to that?
Yeah.
What was that exception we talked about? NH4, right? It doesn't have to be two polyatomic ions, but what if the cation is a polyatomic ion? This one. And so then my formula is, say, NH4Cl. Are there any metals there? Nope. So is it covalent? Why not? Because there's a polyatomic ion there. So that makes the chlorine an ion. So if you see a metal, it's ionic. But make sure you're not also looking at a polyatomic ion. Otherwise, you'll